Hello, this is Susan Poss at Spartanburg Community College, and I wanted to talk with you about parallel and perpendicular lines. And I have a chart here that shows you an example of parallel lines here. In the first example, you can see that these lines are running parallel to each other, meaning that they never touch, they never cross. You can see that noted down here. And on the other side of the chart, you can see perpendicular lines. You can see that these lines do cross, and they meet to form a 90-degree angle. So a couple of things I wanted to point out here in the drawing. These intersecting lines, you can see that they meet here to form these 90-degree angles. And you can see on the parallel lines, I hope you can see this first equation. You can see that the slope of this first line is -3. I'll label it m sub 1. And you can also see that the second line, here's the equation down here, also has a slope, and I'll label that m sub 2, of -3. So that's one of the characteristics of parallel lines. They never touch, and their slopes are equal or the same. And what about the y-intercepts? Well, let's continue talking about the parallel lines here and examine these y-intercepts. You can see that the first red line, the y-intercept, is up here in a positive value. It looks like it's about 1. And for the second parallel line, the blue one, you can see that the y-intercept is somewhere down around -4. So the y-intercepts are different. So a list of qualities or characteristics to know: the lines never touch for parallel, the slopes are always going to be equal, and the y-intercepts are going to be 2 different points. All right, so back over here with perpendicular lines, we already know that these cross and they form 90-degree angles. Where they cross, what about their slopes? Their slopes are what are called negative reciprocals. And what does that mean? It means if you multiply them together, you're always going to get a value of -1. So, for example, if the slope m sub 1 is equal to, let's say, 2/1, then the other slope for the other line is going to be the opposite sign and the reciprocal value. So that's a characteristic that you're going to be looking for when you're talking about perpendicular lines. Do the slopes have different signs, one positive and one negative? And do the slopes have reciprocal numbers, one the inverse or the inverted form of the other? And what about the y-intercepts? Well, you can see from this drawing that the y-intercepts are going to be different. So this is a good summary that you may want to study as you're thinking about parallel and perpendicular lines. So let's do a couple of examples here. What we want to do with this first example is look at these 2 equations. You see I don't have a graph, and I'm trying to decide, are these parallel? Are these perpendicular? Or are they neither? So we need to look at the slope of each line. And on this first one, let me write it down. I can see that the slope of this line is equal to +4. I can see that the y-intercept on this line is at -2. On the second line, second equation, I can't tell you that information yet. I have to get y by itself. So I'm subtracting 4x from both sides. I can now tell you that the slope of this line is -4, and the y-intercept is at 0, +5. So let's do a little checking here. The intercepts are different, so these could be parallel or perpendicular. Let me do a comparison of the slopes. They're definitely not the same. So we know they're not parallel. Are they negative reciprocals of each other? Well, for a positive 4 over 1 to have a negative reciprocal, it would need to be a negative 1 over 4. And that is not what I have here. So on this first example, I'm going to choose neither. These are not parallel because they don't have equal slopes, and they are not perpendicular because they don't have opposite reciprocals of each other. And continuing on, you can see my second example here. Again, neither of these is solved explicitly for y, so let me take the first equation and do that. So I need to add x to both sides. And I need to divide by 2. And let me do a little simplifying here. I can see that the slope on this line is 1/2. And I can see that the y-intercept is at -1. And let me check my arithmetic there to make sure that I did all of that correctly. All right, that looks good. I'm satisfied. So moving on to my second equation. Goodness, I need to do several things here. I think I'll start by just turning the whole thing around so that I already have the y over on the left-hand side. It's okay to take an equation and just completely reverse the two sides. So now I'm going to subtract 3 from both sides. And finally, I'm going to take each of these terms and divide by 4 so that I get y by itself. And you'll notice I did something there in my head. I took this positive 2 over positive 4 and I simplified it down in its reduced form. It's equal to 1/2. All right, so I can now see that the slope of this line is 1/2. And I can see that the y-intercept is at 0, -3/4. And I believe that fits my definition for parallel. The two slopes are the same, and the y-intercepts are different. So I'm going to choose the fact that these two lines are parallel. All right, one more, and you can probably guess that this is most likely going to be perpendicular because I wanted to show you something of each type. So let me take the first equation. And again, I'm going to do what I did before. I'm going to turn the whole thing around and put the y term over on the left-hand side. And the 10 plus 3x, I'm just going to move it over to the other side. And now I'm dividing everything by 5. And I think I'll do one more thing. I'll put this 3/5 x in the lead position over there. And put the 2 second. So now you can see that the slope of this line is 3/5, and the y-intercept is at 2. And then moving on to the second equation and solving it explicitly for y, I'm going to subtract that 5x from both sides. And then I'm going to come through and divide everything by 3. And I can now see, let me clean up that little stray mark there. I can now see that the slope of this line is -5/3, and its y-intercept is at +1/3. So doing a quick comparison here, I see a +3/5 on this slope, and I see a -5/3 on that slope, which leads me to conclude that these are perpendicular. And of course, you can also see that the y-intercepts are different. So I hope that will help you when you need to determine whether lines are parallel, perpendicular, or neither.